will discuss what are the different kind of forces in day-to-day life, means common forces which are used in mechanics. We have already discussed there are total 4 kind of basic forces. So those are the basic forces, but we can derive the other forces from those 4 forces. So in day-to-day life, we have some forces which will be coming into picture, and in most of the question which will be solving in mechanics, we will be having some forces coming into the picture. So first we will study that. So we are going to cover the common forces of mechanics. Common forces of mechanics. So what are these forces? These forces will be occurring frequently in most of the problems. So these are the basic forces which will be dealing in question. So first we will discuss these forces. So first is gravity. So what is gravity? This is the gravitational force of Earth. This is the gravitational force of Earth. Gravitational force of Earth. So gravitational force of Earth on any object. So its value is constant near the Earth's surface. So we will write its value, its magnitude, and different properties related to this. So it is gravitational force of Earth, and what is its value? Its value is equal to mg. Its value is equal to mg, where m is mass of the object, mass into g. So massive the object, more this force. So this force will be acting on every object which is having mass, acts on every object having mass, acts on every object having mass. In some of the question you will be said that some particular object can be considered massless. In that case you may not apply the gravity force. In some of the questions you will be said that this particular object is massless or light. In that case we can neglect the gravity force. What is the direction of this gravity force? So direction. So this is value, this is direction. What is the direction of gravity force? So it is always downward. Always downward, vertically downward. Okay. So this is the thing, and it is coming from what? From which basic force it is coming? Coming from the gravitation. Originated from basic force of gravitation. Originates from basic force of gravitation. Okay. So these are the main things which we should know about the force of gravity. Next, we are going to discuss second force. We will discuss tension. So what is this force? Tension. So tension is a force appearing in string, rope, or thread, those kind of things. So it is a force of pull force of pull appearing in string, rope, thread. These are the words generally used for different problems, so that's why I'm writing this. And how much is its value? So that we will see how much its value, and how it acts, what is its nature, that we will discuss. So it is a force of pull. So if you see, suppose I have an object here and I am pulling it with a string. So if I am applying some force, suppose I apply a force of 10 Newton. So that will be the force appearing in the string 10 Newton. And this 10 Newton force will be acting on the object. So if we have a string connected with the object, the force of 10 Newton will be acting on the string, and that will be the tension in the string. So the tension in a string, we can say it depends upon the other forces which are acting on the string. I will give example. So if I am applying a 10 Newton force here, the same force is appearing in the string and it is acting on the object. So I can give an example for its value. Suppose I have an object whose mass is 1 kg. So its weight will be how much? Mg, that will be 1 kg into 9.8. So that will be 9.8 Newton. So this is the weight of this object, 9.8 Newton. But this object is not moving, means some other force is balancing it. So who is balancing this? So tension from the string is balancing. So tension is acting vertically upward on this object. Okay. Now we take second example. If I have another object which is even heavier, suppose this is 2 kg. So in this case, the weight will be 2 into 9.8. So that is 19.6 Newton. So here also the object is not going down. So the tension in this case is 19.6 Newton. So you can see that the value of tension is depending upon the other forces. The other force, gravity, is acting here. If gravity is less, the tension is also less. If gravity is more, the tension is also more. So the value of tension depends on the other acting forces, or it can be decided with the help of other acting forces. So value of tension is an adjusting force. Adjusting force means its value adjusts itself on the basis of other acting forces. So what we can write is value of tension. It is self-adjusting force. Self-adjusting force. What does it mean, self-adjusting force? The self-adjusting means its value will be adjusted on the basis of other forces. Its value depends on other forces acting on string. Okay, this is one thing. Now if you start increasing the weight here, suppose you apply 10 kg, 20 kg, 30 kg, at some point of time this string will break. So the value is self-adjusting but with some maximum limit. So it is self-adjusting force with some maximum limit. So it is a self-adjusting force with some maximum limit. So whatever is force acting downward, that is 19.6 Newton, that will be balanced with the tension. So whatever force is acting downward, that will be balanced with the tension. So what you have to do is, it is balanced but it has some maximum limit. So that's we can also write with some maximum limit. So that will be given in the question. If some question is related to that, some problem, if it is related to that, you will be provided that maximum tension a string can tolerate is suppose 100 Newton. So the questions are based on that also. Next thing we will write direction of tension. So direction is along the length of the string. Direction is along the length of the string, along the length of a string. So along the length means what? If this is the length, so if you pull this object, the length is like this. So force will always be along the length. But one more thing we should keep, length, along the length you can have either push force or pull force. But in case of string, it is always pulling. Pulling force means on whichever object is applies, it is always away from the object. You can see, if you see this object, the force is away from the object. Here also you can see the tension is upward. So object is here, so away from the object, away from the object. So we should write it is pulling force which also means acts away from object. Okay, if I say, suppose if I say something else, suppose I have a rod. Instead of a string, if I have a rod, the rod can be pushed or it can be pulled. It can be pulled in this direction, it can be pushed. So rod can exert both kind of forces. So if you are pushing it, you are applying the force towards the object itself. So pushing means applying the force towards the object, and pulling means applying force away from object. So for string, we are always having only pulling force. But for rod, if you consider, the rod can exert both kind of forces, pulling or pushing, both force it can exert. But for string, we always have only pulling forces.